now I've just picked some questions to just work through if you would like to see me doing them. So 7A is really similar to above. So we've got 10 bulbs. The probability of being defective is 0.09, which means the probability of not being defective, the failure, is 1 minus this, so 0.91. So for 7A, no more than 2 with defective bulbs. So the probability that X is no more than 2, so less than or equal to 2. So that's 1 minus the probability that, so no more than 2. So that's the probability of having no defective bulbs. The probability of having 1 defective bulb, probability of having 2 defective bulbs. And we're going to do 1 minus this. So that's 1 minus. So the probability of having no defective bulbs, so 10C0, 0.09 no defective bulbs, 0.91 for the defective bulbs, and then we have 10C1, 0.09 where we have 1 defective bulb. No more than 2. Hang on, just let me actually have looked at the worked examples. I may have overthought this. I mean, I'll need all these calculations, but I'm not sure if I'm doing the 1 minus. 1 defective bulb, 0.91 means we have 9 defective bulbs. And then 10C2, 0.092 to defective bulbs, to the 2. And 0.91 to the 8. Let me have a look. Oh yeah, I just didn't need to do the 1 minus. I'm way confusing myself. I do that. Okay, these are calculator jobs. I'm not going to do that for you. You know how to do that. Let's have a look at question 11. So 11A. Oh, I didn't even do B for this one. There will be at least 2 with defective bulbs. So the problem X is greater than or equal to 2 is 1 minus the probability of X less than 2. So it's 1 minus probability of X equaling 0 and the probability of X equals 1. So we've got 1 minus X equals 0 is, I'm not going to rewrite this, I'm going to copy it in. That one. X equals 1 is this one. And calculator. Okay, so for 11, P equals 0.012, which means Q equals 1 minus that, which is 0. Well, it's going to end with an 8, 8, 9. Yep. Okay. And N equals 5 because there's, N equals 10 because there's 10 draws. So we're after P, we want exactly 1 prize. So that gives us 10C1, 0.012 to the 1, 0.988 to the 9. For 11B, then we're going to have, for 11A, II. At least once. Is the complement of not happening at all, 0 times. So probability that x is greater than or equal to 1 is going to be 1 minus the probability that we get it 0 times, which means it's 1 minus, and this would be 10C0 times 0.012 to the 0 times 0.988 to the 10. And for 12, I really wish I had a calculator. For 12a. So, how many times do we have to... So we don't know n here. We know p is 1/6. We know q is 5/6. And we're rolling at least 1/6, which is the opposite of the complement of 0 6s. 0 6s. Which means p, x is greater than or equal to 1, is 1 minus p x equals 0. And we want the probability to come out as greater than 95%. So I'm just going to say 95%, or 0.95, equals 1 minus. And this would be, well, we're doing it n times, nc 0, 1/6 to 0, 5/6 to the n. So now we've got 0.95 equals 1 minus 5/6 to the n. Which means 5/6 to the n is 1 minus 0.95. 5/6 to the n equals 0.05. Let me do the rest of my solution over here. I can't bother going over the page. How well do you guys remember your log laws? If I take the log base 10 off both sides, 5/6 to the 10, to the n, sorry, equals the log base 10 of 0.05. N log 10 5/6 equals log 10 0.05. I mean, you could have just trialed this, by the way. You could have had n equals 1, n equals 2, n equals 3, and just kept cracking it until you got something near 0.95. N equals log base 10 of 0.05 over log base 10 5/6. So that comes out as, and I'm totally cheating, I'm totally looking at the answers right now, if I can find them. Haven't cheated yet, still trying to. Oh, come on. And what was this question? 12a. So that comes out as like 16.431 dot dot dot. Yeah, I did that in my head. So must roll. Now we wanted this to be at least 0.95. So must roll at least means we have to round up 17 times. Yeah, I'm glad you didn't guess and check that, by the way. 17 times would have been hideous. Okay, 12b. What's it asking? How many times must a coin be tossed to the probability of getting one tail? Let me copy this question. Come on. Copy. Paste image. Okay, so this time, probability of tossing at least one tail opposite p x greater than or equal to 1 is 1 minus p x equals 0. So we want 0.99. 1 minus nc 0 half to 0 half to the n. So 0.99 is 1 minus, well, anything c0 is 1. And we went over that, didn't we? Yeah. Anything c0 is 1, so we've just got 1 half to the n, which means 1 half to the n is 0.01, which means n log base 10 of 1/2 is log base 10 of 0.01, which means n is log base 10 0.01 over log base 10 of 1/2, which means we would have had to do it, cheating right now, hang on, 6.644, etc. So at least 7 times. That's how you do those questions.